The IDEC FT1J and FT2J are touchscreen displays combined with PLCs. The dual CPU configuration enables high-speed processing. FT1J has up to 22 I/O points, and FT2J has up to 30. Both units support analog I/O and pulse output. Space-saving, compact design downsizes your equipment. The slim bezel design increases display space. Detachable push and terminal blocks help to reduce wiring time. Both units support a high-speed counter, PID control, and PWM control. Easily manage display and controls for each project with simplified programming. Both units also have a simulation mode. The PCAP touch panel's glass top structure maintains high visibility and display clarity. Unlike other pressure-sensitive panels, the FT1J and FT2J can be operated with a light touch, requiring no force. Designed with new PCAP technology, these HMI screens prevent accidental input from particles and water droplets. They function with or without gloves. The glass top structure is made using tempered glass, making it highly durable and water-resistant. Both the FT1J and FT2J are P66F IP67F rated for cleaning with direct water jets. Maintain a stable performance level over a wide operating temperature range, from -20 to 55°C. Battery power is not required for data storage. No battery replacement, maintenance, or special procedures for transport by air or ocean are necessary. Distance is no issue with the FT1J and FT2J. Remote monitoring and operation can be done from anywhere, at any time. Connect with a tablet, smartphone, or PC, using the web server. A Wi-Fi USB dongle is used for wireless connectivity. You can play sound files with a connected USB speaker. Extensive communication interface enable connection to various devices. Seamless connectivity solutions enable IoT operation. These units support MQTT, Ethernet IP, and Modbus TCP, acting as a gateway between your manufacturing environment and the cloud. Good day, sir. I am from the Technical Support Department of IDEC Company. Today, I will come to introduce the programming method, both in the HMI and PLC parts of FT1J and FT2J to you. Alright, let's get started. First, please open the I-NV4 software. This is IDEC's software that is used for designing touchscreen interfaces. After opening the software, a pop-up will appear for you to select different touchscreen models. Or, if you go to the menu and choose New, the same pop-up will appear. Please select the model that suits your application. The FT2J is a 7-inch HMI plus PLC, while the FT1J is a 4.3-inch one. For now, I will choose the FT2J model, and you can select whether you want the screen to be displayed horizontally or vertically. Then, press the Next button. Next, please select the PLC brand you want to communicate with. If you want to communicate data from other PLCs to the FT2J. For now, I will select Not Use. Then, please press the OK button. Next, a Screen Properties pop-up will appear. Please press the OK button. A new project will then be created, and the I-NV4 software will be ready for you to design a program for your touchscreen. First of all, I'd like to give you an overview of the I-NV4 software, explaining what each tab in the menu does and where you can find various functions. Starting with the round icon with the software logo, if you click on it, you'll find options like New Project, Open Project, and Save Project located there. Next, in the Home tab, the Clipboard section contains commands like Copy and Paste. The Screen section includes commands for creating or deleting screens, and the Drawing section provides tools for drawing shapes, importing pictures, and creating text. Next, the Part section contains the most frequently used group of elements. This includes commands to create various buttons as inputs, lamps to indicate different statuses as outputs, data displays like Numerical Input and Numerical Display to show numbers, various charts, and commands that are often used for writing the program's conditional statements. Next, in the project section, frequently used commands include download, upload, compare project, and communication setting for connecting between the PC and FT2J. And in the edit section, functions like search and replace are commonly used for finding and modifying various devices. Next, we have the configuration tab. This is where you'll find almost all the settings for the various functions of the FT2J. If you click on the Project tab, a pop-up will appear. In the System tab, you can set basic settings like display a picture, startup, backlight, and beep sound. I'll provide more details about this later. Next, in the Communication Interface tab, you can configure settings for RS-232, RS-485, and Ethernet, such as what they are used for and what protocols they use. This also includes USB settings. In the Communication Driver tab, you can simultaneously communicate with up to 3 other PLCs by selecting the brand of PLC you want to communicate with. Communication Driver Network tab for configuring the PLC to communicate with. User Communication tab is used for writing custom communication protocols. Web Server tab for configuring remote control monitoring and custom web page. FTP Server tab is used for configuring FTP functions. Email tab is used for configuring email notifications when the machine encounters issues. In the Network tab, you can configure the use of BACnet IP, Ethernet IP. Here, BACnet IP setting, Ethernet IP setting, and MQTT setting are available for connecting to AWS and Azure cloud servers. Next, there are alarm log, data log, operation log, recipe function, and many other functions that you can configure here. Next, in the Online tab, you can download or upload projects from here, and you can also monitor or simulate them here. Next, in the View tab, you can choose what to display on the left side of the program's workspace. The ones I use most often are the project window, tag editor, object list, and information. The web page editor is used for writing web server code, and the control function is used for writing PLC code for the FT1J and FT2J models. And for the part name, device address, and trigger condition, you can choose to show or hide them. For example, when you draw a button, you can choose to display it in your design area. And for the grid lines, you can choose whether to show or hide them as you prefer. Next, in the Format tab, you can finally adjust the width and height of buttons, as well as their X and Y positions. You can also perform alignments as desired, such as align left, align right, etc. In the next part, I'd like to introduce the Project tab located on the left side of IDEC software. You'll see folders for storing base screens and pop-up screens that you've created. You can right-click and select New Screen, Duplicate Screen, or Delete Screen here. And in the pop-up screen folder, you can do the same thing. And in other parts, you'll notice that project settings and other options are similar to those in the Configuration tab. You can access the settings from here as well. If you scroll down, you'll see a web page editor. If you double-click it, it will take you to a web browser to design your web page. In this section, you can watch tutorial videos on writing IDEC web server from our channel. And for control function settings, you can double-click to open the WindO software, which is the software for programming IDEC PLCs. Next, a tab I use frequently is the Tag Editor tab. Here, you can check the status of your devices to see if they've been used. For example, if you select Target as HMI device and device type, you can check all devices on the HMI side. From here, you can also add comments. The Used section shows how many times a device has been used. If you double-click on Used, it will open a cross-reference for you. This will show you exactly where your device is being used. Next, in the Information tab, if you make a mistake in your settings or programming, an error message will appear here for you to correct. And in these tabs, you can click on the top bar and drag them to where you want. If you're right-handed, you can drag them to the right. Personally, prefer them on the left, and these tabs can be pinned to display all the time. At the bottom left, you'll see the model of the device you're currently using. If you click on it, a pop-up will appear. You can use this to convert your current project or older projects designed for a different model. For example, if you want to convert your project to the FT1J model, select the desired model, choose Zooming Conversion, and click OK. The program will automatically convert your project. Next, at the bottom right, there's a Snap to Grid option. If you uncheck it, your objects can be placed anywhere without being restricted by the grid lines. But if you check it, your objects will be forced to align with the grid lines. And in the grid setting, you can adjust the grid line spacing to your preference. The default is set to 20, and you can also choose the grid color. Note that these settings won't be displayed when you download the program to the actual device. And you can adjust the zoom in and zoom out levels to your preference here. In the next section, I'd like to guide you on how to use and manage screens. To create a new screen, right-click on the base screen folder and select New Screen. The number field is used to identify the page number for reference, and you can name the page in the title field. Once you're done, click OK to create the new page within this folder. And you can edit your page by right-clicking on it and selecting Properties. I'll name this page Page 1, and then click OK. After that, you can follow the same steps to create page 3 and page 4. And if you want to delete page 4, you can right-click on it and select Delete Screen. A pop-up window will appear asking you to confirm. Click Yes, and page 4 will be deleted. And you can open your screen by double-clicking on it. Next, right-click on the base screen folder and select Duplicate Screens. A pop-up window will appear where you can choose the screen you want to duplicate and set the screen number and number of copies. For example, I'll set it to 10 and 3, respectively. Then click OK. You will have 3 new pages added: page 10, page 11, and page 12. Next, if you want to delete multiple pages at once, right-click on the base screen folder and select Delete Screens. You can then click on the first page you want to delete, hold down the Shift key, and click on the last page you want to delete. All pages between the first and last selected pages will also be selected. Then click the OK button. A pop-up window will appear, and you should click Yes to all to delete all the selected pages. Next, right-click and select Reuse Screens. This function allows you to bring screens from other projects into your current project. Then, find and open the other project file. An open screen pop-up will appear. In this example, I'll copy page 10 and page 11, then click OK. You'll see the screens added to your folder. For this tutorial, delete them afterwards. And you can close the screen you're not using by clicking on the X in the top right corner. Next, I'll guide you on how to set the properties for each screen. You can right-click on the screen and select Properties, or you can click on the Design area. In the General tab, you can set the number and title. In the Options tab, you can change the background color to your desired color. Then click OK. The background area of that page will change to the color you've set. For this tutorial, I'll keep the default black color. And you can create an overlay screen. An overlay screen functions similarly to a template screen, which I'll demonstrate for you next. Please click OK to close this pop-up. Next, I'll guide you on how to create a pop-up screen. There are already some default pop-up screens available, such as the numerical keypad. You can create one by right-clicking on a folder and selecting New Screen. In the Settings pop-up, you can define the page number and give it a name. I'll call it Pop-up 1. You can also customize the size by adjusting the width and height. For example, I'll set the width to 400 and the height to 200. In the Options tab, you can also adjust the color and effects. but I won't be making any changes there. After that, click the OK button, and a pop-up screen will appear, which you can design according to your preferences. When you want to use it, you can use the Go to Screen button and select the pop-up to open it. Next, I'd like to introduce you to a method for creating an overlay template screen. The advantage of this is that you won't have to design and edit your objects on every page. By using this method, you can design and edit objects within a single page, and the changes will be applied to every page where you use this template. This can significantly reduce your design time. Right-click on the base screen folder, then select New Screen. For this example, set the number to 100 and the title to Template 1. Then, click the OK button. On page 100, I'll create an example template for you using various objects so you can see how to make an overlay screen. I'll provide more details about these objects later. Go to the Home tab and select Picture. Then, draw on the Design area. A Picture Manager pop-up will appear. Click Import and select the background image you designed. Then, click Open and Yes to all. Next, uncheck the box for your image to keep it stored on your device. If you check it, the image will be stored on an external memory like a flash drive. Then, click the Select button to insert the image into your design. Next, go to the Format tab and adjust your background image to fill the entire screen. You can fine-tune the settings here. For FT2J, the resolution will be 800 x 480, and the X and Y positions will be 0 and 0. Your background image will be resized to fit the screen resolution perfectly. Next, go back to the Home tab and under Buttons, select the Go to Screen button. Draw it on the desired area. Double-click on the button to open the Settings pop-up. In the Screen Number field, go to Page 1. Then, go to the Text tab and in the Text section, type Page 1. Then, click the OK button. Next, copy the button you just created by pressing Ctrl+C on your keyboard to copy and Ctrl+V to paste. Configure this new button to go to Page 2 and change the text to Page 2. Then, click OK. Repeat the same process, but this time configure the button to go to Page 3 and change the text to Page 3. Next, go back to Page 1 that we created. Delete the buttons we made earlier. Then, right-click on the page and select Properties. Go to the Options tab. Check the first option and select Overlay Screen at 100. For the coordinates, set both X and Y to 0. At Display the order of overlapping screens, select Display this screen over Overlay 1. Then, click OK. You will then have the template you designed on page 100 overlaid on top of your page 1. Then, on page 1, you can design anything you want. Next, go to page 2. Delete that button. Then, go to the settings and configure it the same way as page 1. Do the same thing for page 3. If you want to edit your template, go to page 100. For example, if you want to add a picture to your template, go to Picture and select the image you want. Then, adjust the size. You'll notice that if you add a picture to page 100 just once, the same picture will appear on pages 1, 2, and 3. And you can design the other parts of each page as you wish, independently. However, only the objects drawn on page 100 can be shared among all pages. This is a common use case for overlay screens, to save you time on design revisions. You can also try out the simulation by going to the Online tab, then selecting Simulator and clicking the OK button to save your project. A simulator pop-up will then appear. You can try clicking the buttons to switch your screen to each page you design. Then, close the pop-up. In the next part, I'd like to introduce you to the drawing tools. Let's start with shapes. Shapes provide you with basic geometric forms that you can use as needed. For example, let's take a rectangle, draw it wherever you want on the canvas, and you'll get a rectangular box. Next, you can double-click to open a settings pop-up. This will allow you to adjust the line width, line type, foreground color, background color, pattern, round type, and shadow according to your preferences. Once you've finished setting your preferences, click the OK button. You will also get a rectangle according to what you have set. Next, I'll introduce you to the Picture tool. Click on Picture and then click on an empty area. A Picture Manager pop-up will appear. First, I'd like to show you how to create a new folder. Click on the Configure button. A category pop-up will appear. Then, click on the Add New Category button. This will create a new folder. You can also delete it by clicking the Delete button. Click the Add button to create a new folder, and then click the Rename button to change the folder's name. After that, click OK. This will allow you to categorize your images. You can add your images by clicking the Import button. Then, select the image you want and click Open. This will add your image to the Picture Manager. For the checkbox here, if you check it, it means your image will be saved to an external memory like a flash drive. But if you uncheck it, the image will be saved to the internal memory of the touchscreen. You can also choose from the images provided by the software by clicking the symbol Factory button. A pop-up will appear where you can select categories on the left side, such as Round 01, which contains various button shapes. For this example, let's try adding the blower image. Let's say you want to add this image. When you click on it, an image will appear below. You can adjust the fill color mode. For example, you can choose shaded, then select the desired color. Or click Define Custom Color to select additional colors. Click the OK button. You can also flip or rotate your image according to your preference. You can also adjust the background color to any color you prefer. If you click the Default button, the background color will revert to its original setting. Or, if you click Default All settings will return to their original state. And if you want to import an image, simply double-click on the image area. You can then name your image in the Picture Name field. There's also a color exchange checkbox, which I'll explain later. After that, click OK, and then select the desired image and click Select. You'll notice that the image you added has a blue background, which we don't want. To fix this, double-click on your image. Then, press the Browse button. A Picture Manager pop-up will appear. Go to the symbol Factory. In the export options for the selected image, choose a background color. I suggest choosing a color that doesn't appear in your image. For example, let's choose green. Then click OK, and the background of your image will be changed to green. Next, double-click your image and give it a name. Then, check the color exchange box. In the From field, choose green, the same color you selected earlier. Click OK. In the To field, select transparent color and click OK again. Now, you'll have your image with the background removed, which will be displayed as pink in the software. Next, click Select and then OK. Now, your image will have its background removed and you can resize it as needed. This is a typical workflow when using the Picture command. Next, for the Text tool, click on Text and then click on the area where you want to place your text. A property pop-up will appear. Try typing the text you want and then click OK. You will now have the text you created. If you want to edit, double-click on the Font section. You'll find a list of system fonts available. If you use a system font, you can adjust the size here as needed. And you can also adjust the text color. You can choose any color you want. And you can adjust the background color. Then, click the OK button. Next, double-click to open the pop-up. You can select Windows Font. At the Windows Font option, you can click Change, and then select the desired Windows font. After that, click OK, and the selected Windows font will be applied to your text. This is generally how you use the Text command. In the next part, I'd like to guide you on how to use the Buttons command. Please click on the Buttons command, then select the Bit Button command, and draw it in your desired area. You'll then have a Bit Button object. Next, double-click to open the Settings pop-up. First, let's look at the General tab. The first thing I want to introduce is the Action mode. When you click once, it will display various actions such as Set, Reset, Momentary, Alternate, Toggle, and Move. I'll explain how each of these works for you. For the Set action, when you press the FT2J button, it will write a value of 1 to the specified device. When you release the F2J button, no further action will occur. For the Reset action, when you press the FT2J button, it will write a value of 0 to the specified device. When you release the F2J button, no further action will occur. For the Momentary action, when you press the F2J button, it will write a value of 1 to the specified device. When you release the F2J button, it will write a value of 0 to the specified device. For the Alternate action, when you press the F2J button, it will write a value of 1 to the specified device. When you release the button, no further action will occur. However, when you press the button again, it will write a value of 0 to the specified device. For the Toggle action, pressing the F2J button will invert the value of the specified device. If you're using a bit device, the value will flip between 0 and 1 each time you press the button, similar to the Alternate action. For the Move action, when you press the F2J button, it will move the value from the specified source device to the specified destination device. Next, in the Destination Device Address section, please tap on the icon with 3 dots. A pop-up window will appear. At the target, if you select an HMI device, the HMI device is an internal device that will be located on the touchscreen side. Please click on Device Type. The most commonly used device is HMI Internal Relay, which functions as a bit device, displaying either a 0 or 1 status. Next, LDR HMI Data Register is used for data types that are word. If you want to use a specific device, you can simply click to select it from the list, or you can directly input its address number. For this tutorial, I will only introduce these 2 device types. I will not introduce the other types to you yet. Next, go to the target and select Control Device. You can only select FT1J or FT2J models, which are HMIs with built-in PLCs. In the device type, you will find PLC side devices such as Q output, M internal relay, timer, counter, and data register. You can start learning to use these PLC side devices immediately. Next, for external devices, if we have additional connections set up with other PLCs, you can then call up and use devices from those PLCs as needed. For this tutorial, please select the target as the HMI device, set the data type to LM, and the address to 0, then press the OK button. In the right section, if your program doesn't display this part, you can click the Basic or Advanced button here. I recommend selecting Advanced to access all settings. You can only configure this section when you select the Set or Reset action. For example, when you choose Set as the action, MO as the destination device, and write a value of 5, pressing the MO to M4 button will set the value to 1. Next, for the action mode, if you choose Move, you can also specify the source data and transfer. For example, if you set the source device to LMO, the destination device to MO, and the transfer value to 4, when you press the button, the values from LMO to LM3 will be moved to MO to M3. For this tutorial, I'll choose LM5 as the source device and move just one value to the destination device, LMO. Next, regarding the view switching method, the default setting is usually button. This means that your images, when they are on or off stage, will appear as if a button has been pressed. You can select a device address to make your button change its state based on the specified device. This will function like an illuminated push button switch. For example, if you set it to LM10, when your LM10 is in the on state, your button will display the on state image, and if your LM10 is in the off state, your button will display the off state image. And if you select no image, the image for your button will not be displayed. which is similar to hiding the button. However, the button will still function normally. Please select the button first. Subsequently, within the View tab, you can select images for your button in different states. You can specify which image you want to display when the button is on and which image you want to display when it is off. In the Image Type section, if you select Standard and then click the Browse button, a pop-up window will appear. You can select various images as desired, and you can search for other images by changing the type. For now, I'll use the rectangle type. You can press the off or on button to view your image in each stage. I will select this image, and then please press the OK button. On the right-hand side, you can adjust the color of your button. For the foreground color, I will select blue. And for the on state, I will also adjust it to blue. You can press the on or off button to view a preview of your button. Next, if you select the image type as picture, please click the Browse button. A Picture Manager pop-up will appear. You will be able to select the imported image that you desire. Please click on the symbol Factory button. A pop-up will appear. If you wish to use a button or a lamp, I recommend using the Round 01 or Square 01 categories. As an example, I will choose this button. This will allow you to zoom in on your image. I recommend clicking the default All button once to see the original picture. If you select this image, please double-click on it. Normally, if you have not checked the color exchange option, please try clicking the OK button first. Next, please click on the image and then press the Select button. You will obtain the image. In the On stage, click the Browse button and select the same image. Afterward, press the OK button. This pop-up is informing you that your button is outside the workspace. However, it is not a problem. Please proceed by clicking the Yes button. I will move the image into the workspace. You will notice that your button will have a white area in the corner. If you wish to import an image without a white border, double-click, navigate to the View tab, and then toggle the button labeled Off. Subsequently, click the Browse button. Next, please open the symbol Factory. Double-click to import your desired image and assign a name to it. Then, check the color exchange box and click on the color bar labeled From. Next, click on the Define Custom Color button. Select any custom color slot and input the RGB values 254, 254, 254. Then, click the Add to Custom Color button. Then, please click the OK button. For the To option, please select Transparent Color. Then, press the OK button. You will notice that the corners of your image will be transformed into a magenta color. Next, go to the symbol Factory to add another image. I will select a different image and name it On Stage. For the color exchange, follow the same steps as the previous image. You will then have images for both the on and off stages. For the off stage state, I want this image to be displayed, and for the on stage state, I want this image to be shown. Please try clicking the button to view your image. Then, please click the OK button. The white corners of your image will be removed, and you can adjust the size of your button as desired. In the next section, please go to the Registration Text tab. Here, you can select the font you prefer. You can also adjust the line spacing and size. Additionally, you can align the text horizontally or vertically. If you check the Set by State box, you can define what the text will say when the status is off and what it will say when the status is on. Alternatively, if you check the Use Text Manager box, you can select a specific text ID that you've already set up. This is often used for language switching functions, but I won't go into that in detail for now. You can type the desired text to display on your button. Here, for example, I will type Start, and you can select the text color of your choice. I will select the Western font first, and then click the OK button. The button will display the text you have set. You can then return to the settings to adjust the size and color of the text as desired. You will then have a button that matches the settings you have configured. Next, in the Trigger Condition tab, your button will only be activated when it meets the specific conditions you have set in the input condition. If I set the trigger type to while on and select ELM11 for the device address, my button will only be activated when LM11 is turned on. If LM11 is off, my button will be disabled. Additionally, in the visible condition, if you set it to while on and select ELM12 as the device address, your button will be visible only when LM12 is turned on. If LM12 is turned off, your button will be hidden. I won't be using this in this example. Next, in the Options tab, you can set an on delay. For example, if you set it to 10 in units of 100 milliseconds, you will need to hold the button for 1 second before it activates. If you check no touch sound, there will be no sound when you press the button. And if you check place on the top layer, your button will be displayed on the highest layer. I won't be using this example, so please uncheck it. In the Comment tab, you can type any message you'd like. Although I typically don't use this feature, please click OK when you've finished configuring your button. In the next part, I'll demonstrate how to use the bit button. First, let me delete all the objects I've drawn previously by dragging my mouse to select them all and then pressing the delete key. On page 2, I'm going to delete the object first. There's nothing on page 3. As for the template page, I'll delete this image before going back to page 1. Next, I'll go to the Button tab, select Bit Button, and draw a button in the desired area. Then, I'll double-click on the action, choose Set, and set the device address to LM0. In the Text tab, I'll name it SET, and then click OK. Next, I'll click on my button and hold down the Ctrl key. Then, drag the button to the desired location. This will create a copy of the button. Next, I'll double-click on it, change the action to reset, and set the device address to LM0. In the text field, I'll change the name to reset, and then click OK. Next, I'll copy the button again, and change the action to momentary, the device address to LM0, and the text to momentary. Then, click OK. Next, I'll make another copy of the button, and change the action to alternate, and the text to alternate. Then, click OK. Next, repeat the same process, but change the action to toggle. Next, I'll make another copy of the button, and change the action mode to move. I'll set the source device address to LM0, and the destination device address to LM1. Then, out to the text field and change it to move. Finally, click OK. Next, I'll create a sample lamp so you can see the status of the device address I've set. I'll explain the lamp section in detail later. In the trigger condition section for lightning, the default device address is already set to LM0. Press the close button. Next, I'll duplicate the lamp and set its device address to LM1. Then, click OK. Next, I'll go to the Online tab and select Simulator. The software will prompt you to save your project first. Please click OK. A simulator pop-up will then appear. Next, try pressing the Set button. Your device address, LM0, will remain in an on state. If you press the Reset button, LM0 will remain in an off state. And for the momentary button, if you press LM0, it will turn on. But if you release it, LM0 will turn off. The alternate button acts like a toggle switch that stays in its current state until you press it again. So, if you press the alternate button, it will be as if the button is constantly pressed, and LM0 will remain on. Pressing it again will turn LM0 off. The toggle button, on the other hand, simply switches LM0 between on and off each time you press it, without any visual indication that the button is being held down. If I press the Move button, the value from LM0 will be moved to LM1. If I press the Set button, LM0 will be turned on. Then, if I press the Move button, the status of LM0 will be copied to LM1, causing the lamp to also be on. In general, the Bit button is commonly used in this way. After that, please close the simulator. Next, I'll introduce the Word button. Go to the Button section and select Word button. Then, draw it in the desired area and double-click to open the settings pop-up. The Word button works similarly to a bit button, but is used with device addresses of the word type. In the action mode, the first one I'll introduce is Set. With Set, you can define a source data, and when you press the button, the value will be set to the destination address device that you specified. In this case, it would be LDRO, which is a device with the word data type on the HMI side. You can click the three-dot icon to select your device address. You can choose the target as a control device and select the device type as D, which represents a word on the PLC side. However, I won't be using that for now. Please click the close button. For this time, I'll use LDRO. For example, I'll set the source device to 100, which means when I press this button, the value 100 will be set to my LDR0. Next, set the action mode to move. This will allow you to specify a source data. I'll copy this device address and change it to LDR10. This means when I press the button, the value in LDR10 will be moved to LDR0. The move action is commonly used in this way. Next, set the action mode to momentary. The momentary action has two values. Let's say set the on data to 100 and the off data to 0. This means when I press the button, the value in LDR0 will be set to 100, and when I release the button, it will return to 0. Next, set the action mode to alternate. If I set the on data to 100, pressing the button once will change the value in LDR0 to 100. Pressing it again will change it back to 0, alternating between the on and off data values. And frequently used actions include add, subtract, multiply, and divide. Let's say you choose the add action. You can define a source one. For example, I'll copy and change it to LDR10, and for the value, I'll set it to 100. If I press the button, the value from LDR10 will be added to 100, and the result will be stored in LDR0. But if for source 2, you select the device address and copy and change it to LDR11, when I press the button, the value from LDR10 will be added to the value from LDR11, and the result will be stored in LDR0. In the following section, the View tab, you can set various options similar to those in the Bit button. The same goes for the Text tab and the Trigger Condition tab. Once you've finished setting everything, click the OK button. Next, go to the Go to Screen button. Click it, and then draw on the area you want. Double-click to open a settings pop-up. There will be various actions available for you to choose from in the action mode. Choose Switch to Base Screen. This will allow you to set which screen to switch to when the button is pressed. For example, if you want to switch to screen 2, when you press this button, set the screen number to 2. When you press the HMI button, it will switch to screen 2. And what I frequently use is the Open Pop-up Screen function. When you press a button, a pop-up screen will appear. For example, if you set it to screen number 1, pressing the button will display pop-up screen 1 on your HMI. You can also set the X and Y coordinates to specify the exact location where you want the pop-up screen to appear. Another function I frequently use is Back to Previous Screen. This means that when you press this button, the HMI will go back to the previous screen you were on. For example, if you're on page 1 and you switch to page 10, pressing this button will take you back to page 1. The settings in the other tabs will be similar to the previous button I explained. Once you've finished setting everything up, click the OK button. Next, I'd like to introduce you to the Multi button. Click and draw on the area you want. Then double-click to open the settings pop-up. The Multi button works similarly to the buttons we've discussed earlier, but with the added ability to create multiple functions. This means you can execute several actions with a single button press. You already have bit write, right? You can select command type as word write. Then click Add. Let's say I choose action mode as set and value as 100 and destination device as LDRO. Then, click OK, add another Go to Screen action, then click Add and select screen number as 2. Finally, press OK. If you press this button once, All three commands will be executed in sequence. You can customize the settings in the other tabs to your liking, just like the buttons we've discussed earlier. Once you're finished, click the OK button. In the next section, I will provide examples of how to use the buttons that I have previously explained. Before we begin, I will delete the buttons that I have already created. The first button I would like to introduce is the Go to Screen button. I have already created these buttons, labeled Page 1, Page 2, and Page 3, at this location. I've already created this button on page 100. If you navigate to that page, you can modify the button settings by double-clicking on it. In action mode, I will select Switch to Base Screen, and choose 1 for the screen number. Then, I will press the OK button. For the Page 2 button, the settings will be similar. However, you'll select 2 for the screen number and then press OK. The Go to Screen button will be used in a manner similar to this example. Next, we'll return to page 1, and I'll demonstrate an example of a Word button for you. I will draw the button as desired, then double-click on it to open the settings. In this action mode example, choose Add. For source 1, I'll use LDR0. For source 2, I'll set the value to 10. And for the destination device address, I'll specify LDR0 as well. This means I'll take the value in LDR0, add 10 to it, and then store the result back in LDR0. For the View tab, I'll use the default settings for now. On the Text tab, I'll name this button Add. And for the Trigger Condition tab, I won't make any additional changes. Then, I'll press OK, and so, I will now have an Add button. Next, I'll go to the Data Display section and select Numerical Display. I'll demonstrate how to use it first, and then I'll provide a more detailed explanation later. I will draw here, and then I will double-click to open the settings pop-up. In the display device address, I will set it to LDR0, then press OK. Next, I will demonstrate a simulation. I'll go to the Online menu, select the simulator. The software will force you to save, and then press OK. Once the simulator window appears, clicking the Add button will increment the value of LDR0 by 10. Each subsequent click will increment the value by another 10. This is an example of using a Word button to manipulate a Word-type device address. After you've finished experimenting, please click the Close button. This is a basic example of how to use a button. In the next part, I'd like to introduce you to how to use a lamp. Please click on Lamp, and then select Pilot Lamp. Then, draw in the area you want. For the pilot lamp, it will function the same way we used it before. It will be used to indicate the status of our device address, whether it's on or off. Please double-click to open the settings window. In the General tab, go to Action Mode. By default, it's set to No Flash, which means when your lamp is turned on, it won't blink. If you want your lamp to blink while it's on, select Flash, and then set the flash trigger device address. This means that when your trigger device is turned on, your lamp will blink. But for this example, I'll choose No Flash first. Next, on the View tab, the settings will be similar to the button you've tried before. If you choose Standard, you can click Browse and select the image you want. But for now, I'll use the default. Then, click the Close button. You can press the On or Off button to see the status. And you can set the foreground and background colors for both the off state and on state here. But for this example, use the default value first. Next, on the Text tab, you can choose the font you want, such as Windows or Western. I'll choose Western. And you can set the size here and define your text here. Or if you're using a Windows font, you can click the Change button to customize your font as desired. But for this example, I'll use the Western font and leave all the settings as default. Next, on the Trigger Condition tab, in the Lightning section, you can define the conditions that will cause your lamp to turn on or off. In the Trigger Type section here, you can set conditions like while on or while off. Typically, we use while on. In the Device Address, you can specify the device address whose status you want to display, or click the three-dot button here and select the desired device address. For now, I'm going to select LM0. In the Visible condition, it's set to Always Visible by default. If you want to hide your button based on certain conditions, you can set it up in this section. For now, I won't be configuring this part. Next, on the Option tab, you can check the box for Place on the top layer, so that your lamp will be displayed on the top layer. Finally, in the Comment tab, you can add a comment if you'd like. Once you've finished setting everything up, click the OK button. Next, please try the simulator. Go to the Online menu and select Simulator. Then, click the OK button to save your project. The simulator window will appear. This means your lamp is assigned the device address, LMO. So, when you press the SET button, your lamp will display an on status. And when you press the Reset button, your lamp will display an off status. This is the same behavior as the button we created earlier. Then, please close the simulator. Next, double-click to open the settings window. Then, select Flash and set the flash trigger device address to LM0. Finally, click OK. Then, try the simulator again. Press the SET button. You'll notice your lamp will blink even though the device address LM0 is always on. This is a common way to use a lamp. Once you're finished testing, close the simulator. In the next part, I'd like to show you how to use a multi-state lamp. Go to the lamp and then select multi-state lamp. Then, draw in the area you want. For a multi-state lamp, it works similarly to a pilot lamp, but you can have multiple states. The device address used to control it will be a word-type device. Please double-click to open the settings window. The switching method is normally set to value, but you can choose either bit number or value as you prefer. If you choose bit number, your lamp will change its state according to the bit you turn on. For example, if you turn on bit 0 of your device address, the multi-state lamp will display the image for state 0. If you turn on bit 1, it will display the image for state 1. If you turn on bit 2, it will display the image for state 2. And if you turn on any other bits that are not configured, it will display the image for state off. Next, if you set it to value, the state of your image will change according to the value of your device address. For example, if you set your device address to DO, and the value of DO is 0, your lamp will display state 0. If the value of DO is 1, your lamp will display state 1. If the value of DO is 2, your lamp will display state 2. If the value in DO is not within the configured range, it will display state off. This is roughly how it works. Next, go back to the software. In this example, I will use the value method. For the trigger device address, please click the 3-dot button and select device address as LDR1. Then, click OK. Next, go to the View tab. Under Switching Method, you can choose between Standard and Picture. However, for this example, I'll select Standard first. Next, go to the Text tab. You can adjust the font of your text here. Next, go to the State tab. Here, you can set the number of states. By default, it's set to 4 states, which are state off, 0, 1, 2, and 3. And there will be corresponding images displayed below. If you want to add more states, you can press the up arrow button. For example, if you want 6 states, states 4 and 5 will be added. You can also decrease the number of states by pressing the down arrow button. However, in this example, I will use for states. In the settings, if you select state off, you can input your text here and customize the color as you wish. You can see a preview image here. You can also set the pattern and text color. For state 0, the lamp will be set to green by default. You can customize the color if you'd like. Other states will follow the same pattern. However, for this example, use the default settings. Next, we'll go to the Trigger Condition tab. Here, you can set the visible condition. For now, use the default setting. You don't need to make any changes in the Option or Comment tabs. Once you're finished setting up, simply click the OK button. Next, go to Data Display, then select Numerical Input and draw it in your desired area. I'll explain this object in detail later. Next, double-click to open the settings window. In the Destination Device Address field, select LDR1 and then click OK. Once you've finished setting everything up, Let's test your program using the simulator. Go to the online menu and choose Simulator. Then, click OK to save your project. Right now, my LDR1 is set to 0, so my lamp will display the image for state 0. If I change the value of LDR1 to 1, the image will switch to state 1. Similarly, if I set LDR1 to 2, the image will change to state 2, and so on for state 3. If the value is 4, the image will display as state off, because you haven't defined a specific setting for it. This also applies to any other values that you haven't configured in your multi-state lamp. So, that's how you use a multi-state lamp. Once you've finished testing, you can close the simulator window. Next, I'd like to introduce you to the numerical display. Please navigate to Data Displays, select Numerical Display, and draw it in your desired location. After that, please double-click to open the settings window. The numerical display will be used to show the value of your device address. This allows you to see the current value of your device address. In the General tab, you'll find a section called Display Type. Here, you can choose between decimal base 10 and hexadecimal base 16. Typically, we use decimal. Next, let's move on to the data format. Under Data Type, you'll find various data types to choose from, and in the Digit section, you can specify the number of digits you want to display. If you refer to the manual, and if you select decimal for the data type, you'll have the option to choose W or I for the word type. This will allow you to display up to 5 digits. And if you select D or L for the double word type, you'll be able to display up to 10 digits. You can also set it to BCD or float. If you choose hexadecimal display, your options for word type will be limited to W or D. Each data type has a specific number of words associated with it, such as one word or double word. You can refer to this table to see the range of values that can be displayed for each type. For example, W can display values from 0 to 65,535. If you choose I, the values can range from -32,768 to 32,767. And for other data types, please refer to this table for more details. Next, for the floating point display, if you check the option, you can specify the number of decimal places. For example, if you set it to 1, the value read from the device address will have 1 decimal place. For the floating symbol, you can choose what symbol you want to use as a decimal point. Typically, we use a dot. In the Suppress Zero setting, you can choose whether or not to display leading zeros for the device address to fill the entire specified number of digits. For example, if you set digits to 4 and floating digits to 2, and the value in your device address is 1234, it will be displayed as 12.34. Based on this example, if Suppress Zeros is selected, leading zeros will not be displayed. However, if Suppress Zeros is cleared, leading zeros will be added to fill up to the specified number of digits. Next, for the Do Not Display When Value is 0 option, if you check it, it means that when the value in your device address is 0, nothing will be displayed. However, I generally recommend that you leave this option unchecked. Next, for the Display the minus sign and Display the plus sign options, if your data type can display negative values, like the I type, you can choose whether or not to show a minus sign or a plus sign before your numbers. For the symbol to show when out of range or error occur option, you can customize the symbol that will be displayed when the value is out of the acceptable range or when an error happens. In the Display Method section, the Display Device Address option allows you to specify which device address you want to show. You can tap the 3-dot button, then select the desired address. In this case, I'll choose LDR0. After that, please tap the OK button. Moving on to the View tab, in the Image Type section, you can choose between Standard, Picture, and None. If you select Standard and then click the Browse button, you'll be presented with a list of standard images to choose from. Or, if you select the Picture option and then click Browse, you can either choose an image that you've imported or select one from the symbol factory. Or, if you select None, no background will be displayed. For now, please select Standard. Then, in the Plate Color section, you can customize the color as you wish. This includes the foreground color, background color, and pattern. Next, let's move on to the Format tab. In the Font section, you can customize the font to your liking. For this example, I'll choose Western, and then you can adjust the size, text alignment, and text color as needed. Next, let's go to the Data Over tab. If you want to limit the value in your device address, you can select Value and check the minimum and maximum boxes. This will allow you to set a range. For example, I'll set it to 0 and 100. Your value will only be displayed within this range. If it falls outside this range, it will display an error based on the symbol you've previously set. Alternatively, if you choose Device Address, you can set the value based on the specific device address you've selected. Additionally, in the When Data Over section, you can configure it to flash and generate a report when the value falls outside the specified minimum and maximum range. You can also define a device address that will be activated when the value is out of range. For this example, I'll select LM4. Normally, these options are not used, so I recommend unchecking all of them. Next, let's move on to the Trigger Condition tab. Normally, the numerical display shows you the value. However, you can set up conditions to hide the value and only display it when specific criteria are met. But for this example, I'm not going to configure any conditions. Moving on to the Options tab, you can check the display with the Arithmetic Operation box to perform calculations on the values from your device address before they are displayed. This feature is a bit more advanced, so I might not recommend it for now. And there's nothing significant in the Comments tab. Now, return to the General tab. Once you've finished configuring, simply click the OK button. Next, I'll adjust my object slightly. Then, I held down Ctrl and dragged the object to create a copy. Both objects will have the same device address, and the floating digits will be set to 1. However, I'll modify this object by unchecking the Display Floating Point option, and then I'll click OK. Next, navigate to the Online menu and select Simulator. Then, click OK. When I press the Add button, the value in LDR0 will be set to 10. However, this object will display 10, while this other object will display 1.0. If you press the button again, the value in LDR0 will be incremented to 20, which will be displayed as 20 and 2.0 on the respective objects. Once you have finished testing, please close the simulator. Next, I'd like to demonstrate how to use numerical input. Please navigate to Data Display, select Numerical Input, and draw in the desired area. Your numerical input will then be generated. Next, please double-click to open the Settings window. Numerical input is typically used to input numerical values into a specified device address. This means you can click on the numerical input and enter a value in the pop-up window. The entered value will then be sent to the designated device address, as illustrated in this image. Or it can be used to display values. Alternatively, you can use it to enter and display decimal numbers, and you can even configure it to display asterisks instead. Returning to the software, in the upper section, you can simply use the default settings. For this particular part, I won't go into great detail about these settings. As for display type and data format, these settings will be similar to what we discussed for numerical display earlier. If you'd like to review those details, please refer back to that section. The key difference lies in the when input value is out of range, display value near maximum or minimum checkbox. If you check this box, it will function as follows. For instance, if you set the range on Data Over tab to 0 to 10,000 and then input 99999, the displayed value will be capped at 10,000. If you press Enter, the value 10,000 will be assigned to the specified device address. In another scenario, if you input -1, the displayed value will be adjusted to 0. Upon pressing Enter, this adjusted value of 0 will be assigned to the specified device address. This feature is designed to prevent errors from occurring when inputting data into the specified device address. In this example, we'll check the box. Next, in the Input Method section, you can specify the destination device address. For this example, I will select LDR1, which we have used previously, and the focus is moved by Enter button checkbox. If you use this function and have multiple numerical inputs on the same page, normally after entering a value into one, you would need to click on the next numerical input to enter another value. However, if you enable this function, once you enter a value in numerical input A and press enter, the cursor will automatically move to numerical input B, allowing for a seamless and efficient input process. I won't be using this feature at this time. Moving on to the View tab, you'll find options similar to the numerical display. For the image type, you can choose between standard, picture, or none. In this instance, I'll select standard. I'll also change the plate color to make it different from the previous one. Feel free to choose any color you prefer. Moving on to the Format tab, you'll find options similar to the Numerical Display tab. Here, you can choose your preferred font. If you select Windows, you can click the Change button to select a specific font from the list. However, use Western for now, and set this as the default option. And there will be an option to display numerical values with an asterisk. If you check this option, the value of your object will be displayed with an asterisk. You can customize this setting in this section. However, I won't be using this feature at the moment. In the With Unit section, you can append a unit of measurement to the end of the value, such as cm for centimeters. However, I won't be using this feature at this time. In the Change Display Color section, when you activate the trigger device, both the text color and plate color will change to the colors you've specified. In the Flash section, when you activate this trigger device, the text color and plate color will alternate between the default color you've set and the color you've specified for the flash effect. However, I won't be using this feature right now. Next, let's look at the Data Over tab section. I usually recommend setting limits in this section to prevent data entry errors. You can define minimum and maximum values as needed. For this example, I'll set the range from 0 to 100. In the When Data Over section, you can check the report box and specify a report device address. When the value in your device address falls outside the range you've set, this device will be activated. Next, let's move on to the Trigger Condition tab and the Input Condition section. By default, the trigger type is set to Always Enabled, meaning you can input data at any time. If you want to set specific conditions for inputting values into the device address, you can do so in this section. In the Visible Condition section, it's usually set to Always Visible by default. However, you can customize the visibility conditions in the section. For now, I won't be making any changes to the settings. Moving on to the Options tab, you can adjust settings like the No Touch sound. Also, the Input and Display with Arithmetic section is a bit more advanced. Any value you input into your device address will first undergo calculations based on the equation in this section before being sent to the device. On the display, the value from your device address will be calculated based on the equation you've created before being displayed in the numerical input. However, I won't be guiding you through the usage of this feature. Please uncheck all options first. As for the Comment tab, there's nothing crucial there. Once you've finished configuring all settings, please click the OK button. Next, go to Online and select Simulator. Then, click the OK button. Try inputting the value 1 and then press Enter. The multi-state lamp you created earlier will change its state, because we're using the same device address. When you change the value to 2, it will turn red. Generally, the numerical input will be used in this manner. Once you've finished testing, please close the simulator window. Moving on, since this page is full, I'll navigate to the base screen and open page 2. The next function I'd like to introduce is the Message Switching Display. Please navigate to Data Displays and select Message Switching Display. Then, draw it in your desired location. The Message Switching Display works like this. Imagine you've defined Message 0 as drying, Message 1 as heating, and Message 2 as cooling. Whenever the value associated with the device address that you're referencing changes, the displayed message will automatically update to reflect the new value. For example, if the value of DO is 0, the message displayed will be drying. If DO is 1, the message will change to heating. And if DO is 2, the message will be cooling. This is essentially how the message switching display works. Returning to the software, please double-click to open the settings window. On the General tab, under Message to Display, there are various settings available. For now, let's select Specify by Message Number. For the device address, please click the three-dot button and choose LDR5. Then, click OK. Next, let's move on to the Message tab. Although you can use it as a text manager, we'll cover that in more detail later. You can customize the text for each message number right here. For example, I'll set the messages as Text-O, Text-1, Text-2, Text-3, and Text-4. Let me demonstrate this with 5 messages. First, if you select Yes in the column change section, you'll be able to customize the color of both the text and plate. Now, please try customizing the colors of the text and plate to your liking. Additionally, the message switching display can accommodate up to 1,000 messages. Next, let's move on to the View tab. The settings here are similar to the other functions we've already discussed. You can customize your image and adjust colors. For this example, I'll use the default settings. Next, let's move on to the Format tab. Here, you can customize the font to your liking. You can customize the display colors and even adjust the flash settings. However, I won't be using these features for this demonstration. Next, we'll move on to the Trigger Condition tab. Here, you can set the visible condition. By default, it's set to Always Visible, but I won't be making any changes to the setting in this example. As for the Option and Comment tabs, there's nothing critical to note there. Once you've finished making all your adjustments, simply click the OK button. Before running the simulator, go to Data Displays and select Numerical Input. Draw in the desired area, then double-click to open the settings window. For the destination device address, I'll set it to LDR5, which is the same as the previous message switching display. Then, click OK. Next, go to the Online menu, select Simulator, and then click OK. Once the simulator window appears, go to page 2. The message will initially display as Text-O. However, if you've set your LDR5 value to 1, the message will then display according to the content you've defined for message number 1. If you change the value to 2, the message number 2 that you've set up will be displayed. Then, you can test the system as you wish. So, this is how the message switching display will function. Once you've finished testing, please close the simulator. Next, I'd like to introduce the Character Input function. Go to Data Display, then select Character Input. Draw in the area you want, and you'll have your own character input object. Next, double-click to open the settings window. Character input is typically used to enter character values into the desired device address. For now, please use the default settings in the General tab at the top. Moving on to Data Format, under Input Digits, you can specify the number of characters you can input and the number of characters to display. In this example, I'll set both sections to 20 characters for now. Next, under Destination Device Address, you can specify the device address you want as your character. Be careful not to overlap your devices, because one word can hold 2 characters. I'll be using LDR10. Now, this object will reserve device addresses LDR10 to LDR19 for you. The right null after the end of the string checkbox is usually checked by default. This means that a null character will be added after the last character of your string to indicate the end of the string. Next, on the View tab, the settings will be the same as what I explained earlier. For the other objects, you can customize the settings as you like. For now, I'll change the color of the plate to my desired color. Next, on the Format tab, you can customize the font, size, and text alignment to your preference. And you can adjust the text color to your liking. And if you check the display character with asterisk, your characters will be displayed with an asterisk, and the other parts will be the same as I explained before. Next, on the Trigger Condition tab, it will be the same as what I explained earlier. For the other parts, you can set the input condition and visible condition. In this section, won't set anything. Next, on the Option tab, there's nothing important. And on the Comment tab, there's no need to set anything. After you finish setting all the options as you want, just click the OK button. For this example, I want you to copy another one. Hold down the Control key on your keyboard and then drag the object. Next, double-click to open the settings window and change the destination device address to LDR20. Next, go to the View tab. Under Plate Color, change the color to something different from before. Then, click OK. Next, try the simulator. Go to the Online menu and select Simulator. Then, click OK. Go to page 2. Then, try inputting any value you want. You can input up to 20 characters as you've previously set. After that, press Enter. Then, try inputting a value in the other field. You can choose between lowercase or number and sign. After that, press Enter. The string you input will be stored at the device address you specified. Next, you'll monitor the device. There are two monitoring modes, Batch and Custom. I recommend using Custom Monitor. Next, go to the device address and set it to LDR10. Choose the data type as string and set the word to 10. Since one word is equivalent to 2 characters, you'll see the data you input in LDR10, and the other one will be LDR20. Please set it up the same way. You'll see the string value stored in the device address you specified. When you're done with the experiment, please close it. This is typically how character input is used. Then, exit the simulator. Next, I'd like to show you how to use Message Display. Go to Data Display, then select Message Display. Draw in the area where you want to display the message. Next, double-click to open the settings window. Message Display is used to show strings or characters from your device address, as well as any text you want. You can set the device address for each channel. Here, for example, double-click and select LDR10, then click OK. Next, specify the number of words you want to display your string. In this example, it would be 10 words. For the next channel, set it to LDR20, and set the number of words to 10. To display your string, use the backslash symbol followed by the @ sign. It will display channel 1 that you've set up. Then, press Enter and type a backslash followed by an @ sign. It will display channel 2 that you've set up. You can use more than one channel, and use the backslash followed by the @ sign to display the value for each channel in order. Next, in the View tab, the settings will be similar to the other functions I've mentioned before. You can customize it to your liking. Next, in the Format tab, you can do things like scrolling text, changing the display color, or making it flash. However, I won't be using these options in this example. Next, in the Trigger Condition tab, I won't be setting anything. And in the Option tab and Comment tab, I won't be setting anything either. Then, go back to the General tab to double-check everything. Once you're satisfied, click the OK button. You will then see the message display as you have set it up. Next, adjust the size to fit. Next, I'll copy another one by holding down the Control key on the keyboard and dragging it, then dropping it. Next, double-click to open the settings window. For this example, I'll show you how to do scroll text. I'll move the backslash at up one line. Then, go to the Format tab and check the scroll checkbox. Finally, click OK. Then, please adjust the size of your message display to an appropriate size. After that, please go to the Online menu, select Simulator, and then press the OK button. Please go to page 2, then try to input your text in the character input that you created earlier, and then press Enter. You will see your message on the message display. Then, try inputting another message and press Enter. Another set of messages will be displayed on your message display, while the other message display will show the messages in a scrolling format. For the message display, you can directly define the text, or you can display the text from the device address that we have specified. This is generally how the message display is used. If you have finished testing, please close the simulator. For the use of FT1J, FT2J PLC plus HMI, especially in designing HMI screens on IDEC software, I will only give you this much introduction for now. There are many other commands that I haven't introduced in this basic tutorial, such as alarmless display, data log display, picture display, and various charts. I will create a video tutorial for these features later. That concludes our introduction to HMI programming for part 1. Stay tuned for part 2, where we'll delve into PLC programming. I hope you found this tutorial helpful. Please like and subscribe to our YouTube channel for more tutorials and product updates. If you have any questions or need assistance, feel free to contact IDEC or your local distributor. Thank you for watching.